All right, well, believe it or not, this is the last lesson of the unit. It's been a long unit, a lot of talking about linear relations. Now, the last couple of days, although it is related to linear relations, it hasn't been quite the same as the stuff that we spent so much time on, where we did, rules for patterns and that kind of thing. We spent a couple of days doing stories, talking about stories and representing those with graphs. We called them story graphs. And today is something, again, even different. It is related to all of this stuff. It's still graphing, as you can see here, but it's scatter plot, so it is a bit of a different kind of a graph. And we're just doing one day on it, okay? So we're going to talk about what a scatter plot is, talk a little bit about when you're going to see it in real life, because, or even in math class, because I think that's going to help us understand what they're all about. We're going to talk about something called a line of best fit and talk about what that means. And then we're going to do a little bit of interpreting them and using them and that sort of thing, which hopefully you'll see is similar to a lot of what we've already done. Okay. Now, first of all, what is a scatter plot? Well, a scatter plot is called that because the data is scattered on the graph, not in a perfectly straight line. Up until now, we had a rule, y equals, or let's do this, c equals 50 plus 5t or something. So it starts at 50, and every time it goes over 1, it goes up 5, up 5, up 5. And it's going the exact same amount up all the time. And that makes a perfectly straight line, perfectly straight. We talked about that. If you have a point that's off, you've done something wrong, okay? That's almost everything we've done up until now has been based on that. You can see right here, those points are not in a perfectly straight line, but that's often how things actually happen in the real world. If you're collecting data, if you're a scientist, you're taking measurements, things aren't going to be perfect, okay? So the data is a little bit scattered. That being said, this is a great example of data that is scattered, but still looks like there's some kind of pattern or trend, right? Because there's no points up here, there's no points down here, and it is kind of going from down in the bottom left to up in the top right and kind of generally following that up to the right kind of a pattern. And we call that a pattern or we call that a trend. Um, and that's what a scatter plot is. And we can answer questions with scatter plots, but one of the things we like to do is just draw a conclusion, which has to do with, is the data going up to the right, like this data is, or is it going down to the right? And we'll see examples of that later on, okay? And that's just called the trend. Generally speaking, what direction, if any, is the data heading? Now, when would you have a situation like this? Well, everything we've done about cost structures. So, a gym membership, you pay $50 and $5 per class. That is not a scatter plot because it's a formula that's used to calculate how much your cost is. What about this though? What if you took measurements of your height over your from when you were 1 year old to when you were 18 years old? Some years you're going to grow more than others. So this is a year where you grew a lot, but this year you didn't grow a lot, right? Now this wouldn't make sense for that because you would be growing and then shrinking, and that doesn't happen. But if this was different people along at that time, then maybe it would make sense. But anyway, let's ignore the ones for now that don't make sense. And let's just think of this as your height changing over time. Okay, so you grow a lot. Sorry, you don't grow a lot. You have a growth spurt that year. That year you don't grow very much. You grow a lot. That one was kind of medium. That one was very similar, and this one is almost no growth. So there was growth every year, but some years more than others, and that's why it doesn't make a perfect line. But the point is that generally speaking, you're getting taller over time. right? There's a trend here. It's not random. It's not like, oh, I just happened to grow. No, we know that people grow over time as in their younger years, at least. After 20, you don't grow much, but before that, you grow every year, right? But some years more than others. And that's what happens with the scatter plot is when the data is not perfect, but generally speaking, it is trending one direction. Let's bring those other dots back. And usually what we would do at this point in the class is we would try to guess at what this graph here could represent. So I gave us one example, and that was height and time. Okay, and often we would have time as the horizontal axis, right, the bottom axis. And often this one for us has been distance, and height is a type of a distance, but it doesn't have to be. Now, I would never put time up here because we're not going to get into this, but we've talked a little bit about independent and dependent variables and which variable causes which, right? And as time goes on, you grow. It's not as you grow that makes time happen. Time passing makes you grow taller. So the thing that's making the other thing happen is the one that goes down here, right? Height happens because of time. So height goes on this axis. So it is something you want to think about. It won't be too much of a deal for this course. Later on in high school, that might matter more. Okay, so let's see if we can think of some other things. Height over time or height and age would be another one, right? It could have been age instead of time. That's kind of a similar way of saying time. What is something else that this could represent? Well, it could be your money in the bank. So money and time. And, 1 week you gain money, but then you spent money and you didn't work. You gained money, gained money, gained money, gained money, spent money. Like that would make sense, right? So you can gain money and spend money. But generally speaking, over time, the amount of money you have is going up. What's another one that it might be? How about this one? Um, Ice cream sales. And temperature. So what does that mean? That means the more the temperature increases, so this is colder temperatures and this is hotter temperatures, right? If the temperature here is like 0 degrees Celsius and the temperature here is 30 degrees Celsius, that's the difference between winter and summer. So in the winter, you might sell a little bit of ice cream. People still like to buy ice cream, but in the summer, you're going to sell more. So ice cream, the amount of ice cream sold goes up as it gets hotter. That's another example that doesn't involve time, um, but it would have a relationship there. Okay, and we could describe it by saying the as temperature increases, the amount of ice cream sold increases, or more ice cream is sold when it's hotter, right? Something like that is how we would describe that. One trick that I really like is putting a circle around the data and looking at the shape of the circle. And I can see that this circle is skinny and long, and it's definitely leaning that direction, okay? And this one's fairly steep, right? So this one, when I draw a circle around it, again, is going up to the right, but not as fast. The other one was kind of going like this. This one's not going as fast. This one looks like it's not starting at 0. So this one's probably partial variation. This one looks like it could start at 0. It's a good thing to note that these don't have to. This is still going up to the right, but these dots are even closer. Like they are more compacted, all kind of bundled closer together, whereas these ones are more, there's more space between them. They're spread out a bit more, right? So this is a stronger relationship, whatever is causing it. This one's a bit of a weaker relationship, but still pretty good relationship. That's something else. We're not going to talk about it too much, but something else we do talk about in math is how strong a relationship it is. okay? And those are both examples of scatter plots that are going up to the right, but they do look a bit different from each other, okay? So whatever we chose to represent this graph could also represent that graph, right? What about this one? What's different about this one? What happens when I draw a circle around the graph? It's going down to the right. That pattern is definitely going down, right? So now we can think of um, what would this be an example of? What might this be a graph of? Well, this could still be money in your bank account over time if you're spending more money than you're making, and some weeks maybe you get a little bit of money and you don't spend, but some weeks more often than not you're spending your money. Okay, that's something. And what else can you think of? This is a good challenging one to think of things that this graph could represent. I'll try to think of some that people have said in other years. Um, this was a good one. The amount of snacks in the house, and the hours of TV watched. So what does this mean? Somebody came up with this a couple of years ago. It means the more hours of TV you've watched, the less snacks you have in your house, because as you're watching TV, I guess you're eating snacks. So the amount of snacks goes down as the hours of TV watched increases, because this is hours of TV going this way. So this is increasing going this way, right? Okay. Or another one, hours of TV watched and time studying. Because presumably, if you are watching TV, you're not studying. So the more hours of TV you watched, notice that you didn't study very much. But if I didn't watch much TV, I did study more. Okay, so that's how that relationship works. Or time spent exercising versus hours of TV watched, something along those lines. Okay. Another one that somebody came up with was diapers used. Diapers used. And your age. So when your age is small, you use a lot of diapers. Okay. But when your age is bigger, you don't use a lot of diapers, and eventually you use none. And then somebody often says, oh, but when you're older, you use diapers again. So what would happen here for most people is it would go down to 0 for a long time, and then it would start going back up again, right? And that certainly can happen with these plots. For us, usually it's going to kind of, we're not going to look at it over an entire lifetime, so we won't see it go back up, but that certainly can happen, okay? So people often find it harder to come up with examples for this one that's going down, but there's a few at least to start thinking about, okay? And finally, what's different about this one? Well, it is not a straight line. This is a curve. So this is a non-linear relationship. So there's a pattern, but it's curved. And if I was trying to show the trend, I would have to draw a curved data. And what could this one represent? This one might be how fast you are as a runner. So running speed and age. Okay. So when you're a baby, you don't run very fast. When you're, in your late teens or middle age, you're running your fastest. And when you get older, you can't run anymore. So you're slow again. And there's lots of things that could go up and then go back down in a sort of curved fashion like that. Okay. And we'll see a little bit of relationships that are curved like this as well. Okay, something that I've already done a few times but I haven't really talked about yet is something called the line of best fit. A line of best fit is a way of sort of taking an average on a graph, okay? And so we're going to talk about this a little bit. We're not going to get too much into it. It can be tricky. We don't have enough time to really nail this. Okay. But if you have a set of data like these two, we're going to do one for each, and you have to draw the line of best fit. This is what you want to think about. Your line must show the trend. Must, must, must. What does the trend mean? The trend is the pattern in the dots. Okay, so this one, I've drawn a circle around it. It's clearly going down. My line of best fit has to also be going down. What about this one? Well, this one's going up, even if it's kind of gently, not really steep, just kind of like a lot less steep, but still going up. So my line has to look that way. And what people do is they draw a line. They always start at the origin and go like this. And that does not at all represent this data, does it? That line would be terrible for this graph. So that would be bad. Or even doing this, somebody's forcing it to go through the origin, and that's not showing the trend because the trend of this data is following that kind of a line. Okay, I'm going to do a better line of best fit in a second, but it's that kind of a thing. That's what we mean by showing the trend. This shouldn't say must. It's not, the 2 and 3 are not, or question number 2, sorry, is not mandatory, but it says there should be as many points above the line as there are below the line. That's an average. Like, you want to be close. So if you have 6 above and 4 below or something like that, it's fine. As long as you're showing the trend, that's the most important thing. But that's something to think about. If you're deciding whether your line should look like this or like that, like sort of deciding between two different lines, you could try counting the dots and decide which one has closer number above and below the line. So it's something to think of. You can also try to get a bunch of points on the line. Sometimes that's good to do. What you don't want to do is just pick the first point and pick the last point and just connect them. Okay, that's all. That's not how you do it. Okay. And point number 3 here is the line does not have to go through the origin. I kind of commented on that. That's what people like to do. They like to start at the origin and just have it go up from there. That is not going to be good because it doesn't show the trend. Okay. This is often where we stop, and I'm going to draw the line of best fit for these two, but there is a Desmos activity, so we might be doing that in class, in which case we would pause here and do that activity, but we're going to skip it for now, and I'm going to just do the line of best fit for these two. Whoops, I wanted to keep that there. And then we're going to move on and look at some more material on line of best fit. Something that you want to do is, if you have a clear ruler, it's great because I can see the points through the ruler. Okay, and what I do is, first of all, I already said this data goes down to the right. So I don't want my ruler anything like this. I want it going down. And what I'm going to do is I'm going to kind of get it in those dots, and then I'm just going to play with it back and forth. So I'm moving it up and down, and I'm tilting it back and forth until I have a line that I'm happy with. And this kind of looks like a point here, and part of me feels like I want my ruler to go through that, but it doesn't have to, okay? So I might do something like this, and it doesn't have to be perfect. And I'm going to do my line through there. So I got a bunch of points on the line, and I've only got 3 above, but I've got 1, 2, 3, 4, 5 below. But the 3 above, this one's really far away, so it kind of balances out. Okay, so that's a pretty good line of best fit that I've drawn there, and that's a line that kind of represents all that data. Let's do another one. You'll notice that when the points are further spread apart, it can be harder to do. So I'm going to do something like that. Maybe tilt it a little bit. So I'm getting all those points on the line. And I've got 1, 2, 3, 4 kind of below the line, 1, 2, 3, 4 kind of above the line, and 4 kind of on the line. So that one averages out nicely like that, okay? This first line's going down to the right, the second one's going up to the right, and they're following the trend. That's really, really important that you understand what I mean by following the trend, and how you can see the pattern in that data, and my line is showing that, okay? This one's going up as it goes over, and so is my line. This one's going down as it goes over, and so is my line. Okay, scatter plots and lines of best fit. I don't know why this has another title. Example 2, making and using a scatter plot. So we're going to make a scatter plot for the following data. Now you'll notice that most of these points have already been plotted to save us some time, and I believe that all of these are done. Okay, and if you are doing this yourself, or you might just check them off as you're done to make sure that you don't miss any. And I think the first and the last are the only two that are missing. So hours spent studying, 4 hours, and exam mark is 65. So this is going up by 10. So 65 is halfway between those two. So I'm going to go from 4 and I'm going to just eyeball it at 65. So that one's done. And at 6, I've got a 77. So 70. This would be 75 halfway. So I'm going to go a bit above that. Okay, I don't have to be perfect. I don't want to be too close to the top here because that looks more like 78 or 79, and I don't want to be down here because that's below 75. I want to be just over half, okay? Something like that. So there's the 2 points, and that should be all of the points that are in the table. But generally, you might have to plot all of them for your homework, for a quiz or a test. You know, if you're lucky, we'll only make you plot a couple of extras, and we'll give you the rest already on the grid just to save some time. Okay, draw a line of best fit. So are we starting at the origin and going through the points? No, because look at where this pattern is, or this data is starting. It's starting right here. In fact, we have a point on that axis there. We don't have to use it. I'm not just going from endpoint to endpoint, okay? So in fact, I'm gonna go up a little bit because that looks more to me like the average is right around there. Now I'm gonna cheat a little bit and I'm gonna actually have it start kind of right at 40. And that's just gonna make my life easier because then I have a nice place where my line starts, which may or may not be helpful. And I'm gonna go up past to the end of the grid. And again, I don't have to use that point as my start. It's not wrong to, but I don't have to. I don't have to use that point as my end. I'm not just connecting the dots. I've got a bunch of points above the line, a bunch of points below the line, and that is my line of best fit. Describe the trend of the data. So this is where we have to make sense of what's happening here. We haven't even talked about this yet. Hours spent studying, mark on exam. So this is hours down here. And this is mark up here. And what does this mean and why does it make sense? The longer you study, the higher your mark. And doesn't that make sense? The less you study, the lower your mark. And that makes sense. So these are, what is this, 12, 13, 14 different students, presumably. And they've all studied for different lengths of time. Sometimes you might have 2 people who studied the same amount of time. That could certainly happen. They're different people, both studied 4 hours, both got different marks on an exam, right? They wouldn't necessarily get the same mark. But generally speaking, what this is showing is that for this class, the people who studied more got better marks on the exam. And we should probably believe that that's the case. It's not going to be true for everybody. Look at these 2 points. This person studied more and got a worse mark. Why? Maybe they didn't study very well. Maybe they were distracted, something like that. Maybe this person does really well on exams naturally. Like, who knows, right? Look at these 2 people. This person studied a lot more and got and failed. This person didn't study very much and got a decent mark, 70%. So everybody's different. Some people might be a little bit more comfortable with the content of the exam, whether this is math or some other course, right? Who knows? So there's other factors that go into it, but generally speaking, this data shows that the longer you spent studying, the better your mark was. So that's what we're going to describe. We're going to describe the trend of the data. So the longer studying longer usually gets better mark. So this is just kind of my own sentence that I came up with that's describing this situation, and that's a fine way of describing the data just in your own words. Okay, this, I'm going to show you another way that we could do it, which could be like a math class way, kind of, you might think about it. And this, I can basically adjust the sentence I'm about to, the statement we're about to make to any situation. So I would say as the number of hours, as hours increase, mark increases. Because I could also, or if it was the other way around, I could say as hours increase, mark decreases. As hours increase, the higher the mark, sorry, the higher the hour spent studying, the higher the mark, right? So I'm saying both are going high at the same time. The other thing that might happen is as it's going down, I would say hours are getting bigger, but mark is getting smaller. Okay, so it would be one or the other if I was going to say it, make the statement like this. That's why it's a nice thing, because it kind of always will work. One of those two things. Okay. And I don't have to say anything about how strong it is or if it's really steep or anything like that. I'm just describing the trend. Basically, is it going up or is it going down? But you want to talk about both things. You want to mention hours and you want to mention the mark. Okay, you have to mention both. Use your line of best fit to predict what mark you would expect someone who studied 9 hours to get. So what I do is I take my ruler, I don't just eyeball it, I take my ruler, I make sure it's straight, I go to 9. Okay, use a different color so it stands out, and I usually do a dotted line. You don't have to do a different color, you can just use your pencil. But I just want to make sure that my line is straight, and then I want to make sure that it's meeting on the line, and it's just below 90. So I'm not going to say 90 because I can see that it's just below. So I would say somebody who 9 hours, about 89%. Okay. Use your line of best fit to predict what mark you would expect someone who studied 2 hours to get. Now this one's interesting, actually for a couple of reasons. It's interesting because there's a point at 2. Now my graph happens to go through that point, my line, sorry, but what if it didn't? If it didn't, I want to use the line, not the point. Okay, so in this case, it does go, whoops, I'm going to use red again. It does go through that point. That was that. At 2 hours, it was 50 bang on. It wasn't 51, but I'm not using this row of the table. I'm using the line. Okay, so it is going to be about 50%. But just hold on a second. Don't write any of this down. If my line, if I drew it like this for some reason, then I would have followed up to there and followed it over till that looks like about 55%. Okay, and that would have been the right thing to do. It would not be okay to just use the point if my line doesn't go through the point. But if my line goes through the point, then definitely I would end up using that point. Okay, finally, use your line of best fit to predict the number of hours somebody studied if they got a mark of 65. So in this case, I'm going to 65, so I got to eyeball that. It's about halfway. And I'm going to follow that over. Use a different color this time. Okay, and then follow it down. So it looks like just under 5, so maybe 4.8. 4.8 hours. Just estimate it, doesn't have to be perfect. People always worry, what if I said 4.9? What if I said 4.7? Those would be fine. What if you said 4.5? Well, it's definitely over half, so I wouldn't say 4.5. What if you said, or sorry, over half this way? What if you said 4.1? It's definitely not 4.1 because that would be around here. Okay, so it is past halfway of 4, somewhere between 4.6, 4.7, 4.8, 4.9, something like that. I chose 4.8 hours, okay? Something along those lines. So that's where we're using our line of best fit to come up with some predictions, some estimations, okay? Last thing we're going to do is we're going to do a few multiple choice questions. Again, these look a lot like EQAO. Scatter plot below shows data from an experiment. Which of the following best represents the trend in this data? A line that starts at 0.10 and ends at 1.50. So 0.10 is here, and 1.50 is 1.1, 1.2, 1.3, 1.4, 1.5 there. So a straight line that goes between those 2 points. Is that a good demonstration of the trend? I mean, it's definitely going down, but let's wait and see. A line that starts at 0 and goes to 1.6 and 12. No way. That's going totally the wrong direction. What about a curve that starts at 0? No. A curve that starts at 0 and 10 and ends at 1.5. Well, don't you think that is the best? So it's starting here and it's curving and ending there. So the green line looks better because it goes through all, and it's a smooth curve. I'm not doing this to hit all the points. I'm not connecting the dots. It's a smooth curve. I don't think a straight line is good. I think it's C, a curve that goes through those points. Which scatter plot shows data with no trend? Okay, let's look at each of these. A. Okay, first of all, actually B clearly shows a trend. It's going down to the right. There's a pattern. There are no dots down here. There are no dots up here. They're all in this circle, so that's reasonable. This one is a curved pattern, but again, I could draw a line of best fit, couldn't I? Same with this one. I could draw a line of best fit. That makes sense. Okay, so it's not B and it's not D. What about A? Well, it's flat, but that's okay. That's a trend. I can still draw a line of best fit through it. There's no points down here and there's no points up here, so it's not just random. There's something going on there. That brings us, so I don't think it's A, that brings us to C. C has points everywhere. There's no trend. If I draw a circle, it's just around the whole graph. There is no trend here, and that's what it's asking. There's no point in drawing that. That's not showing a trend, or that's not showing anything. I don't just connect the dots like this. This doesn't make any sense, okay? So C, in this case, doesn't show any trend at all, whereas the other ones all count as trend. Some people might think A is no good because it's flat, still could be a trend. Some people might think D is no good because it looks curved. Trends can be curved. That absolutely happens, okay? And that's the last question. I hope that makes sense. That's the end of the unit, but today was different. It was all about scatter plots and points that don't form perfect lines, but doing a little bit of work with the trends and lines of best fit, and just thinking in general about those properties, them using them, that kind of thing, and thinking about what they represent. That description of the trend is really, really important. I hope that makes sense.